Hey class, this is Mr. Roberts at Shasta High School. I have a select few problems that I'm going to be looking at with you in this video from section 2.5. We were dealing with absolute value equations and absolute value inequalities. So let's fly through these pretty quickly. The first problem here asks us to solve the equation, the absolute value of x minus 12 equals 5. And recall that whenever we're looking at an equation with absolute value, it's impossible for it to be an and relationship, because you can't, for example, be the number 2 and the number -3, right? You can be one or the other. So equalities are always going to end up being an or relationship when we solve them. And the mechanics are pretty straightforward. Remember, we're just going to write the word or. That's a very thin pen. Let me see if I can make this pen, this ink thicker. Okay, that should be a little bit better. So we're going to have an or relationship here. And I essentially write this twice. Remember, the price to pay in order to get rid of the absolute value portion of this equation is we have to consider the two locations that are 5 units away from the origin. And in both cases, we've got one that's the plus, and we've got the one that's the opposite of that. So this illustrates what we do in just about all of these equations or inequalities that involve absolute value. We're going to break it up into two cases. One's the positive and one's the negative. Now, the one that's on the left-hand side of this, or, it has the plus outside. If I distribute it, it doesn't change it at all. So, or if I multiply both sides by +1, it doesn't change it at all. So I can just drop that, and this becomes x minus 12 equals 5. And if I add 12 to both sides of this equation, I get that x is equal to the number 17. Or there's another value of x that will work. My recommendation is when you have this negative outside of the parentheses, that you go ahead and multiply both sides of the equation by -1. We know that if I have -1 and I multiply that by a -1, that equals +1. That will force this to become a positive, and I can drop the parentheses just like I did on the left-hand side of the or. So this will become x. I'm dropping the parentheses, I said. This will become x minus 12. But remember, if I multiply one side of an equation by a number, in this case -1, I have to multiply the other side of the equation by -1 also. So both the left-hand side and the right-hand side are being multiplied by -1. On the left-hand side, it forces this to become positive x minus 12. And over here, I'm going to pick up a -5. Now I'm going to still add 12 to both sides of this. But in this case, when I do it, a little bit different result. I get that x is equal to +7. So there are two values that x can be. X can be 17 and x can be +7. Now if I consider both of those real quickly, just a substitution in here, if x is 17, 17 minus 12 equals 5. The absolute value of 5 is 5. So we can see that this side checks. On the other side, if I plug in 7, 7 minus 12 is -5, and the absolute value of -5 is 5. So this checks as well. Not to do a lot with question 17, but I just want to point out that remember the definition of the absolute value, and remember the cases that we considered in class. Is it possible for the absolute value of something, here's the something, is it possible for the absolute value of something to produce a negative result? So be aware of that, and this problem should be pretty straightforward. If you go ahead and do the whole thing, what you're going to find is that the values you get when you plug in, I highly doubt they're going to produce a -9. Let's go to 21. In 21, we have here the absolute value portion of this equation is not isolated first. And we're going to solve this by isolating that absolute value portion first. To do that, I'm going to divide both sides of this equation by 2, or I could multiply both sides of the equation by 1/2. In any case, the equation becomes x, the absolute value of x minus 6 equals the number 24. Again, I divided both sides by 2. Again, to get rid of the absolute value portion of this equation, I have this trade-off. I'm going to consider both x minus 6, the positive case, or I'm going to consider the negative case, x minus 6 equals 24. Over here, just the positive doesn't affect this at all, so this is x minus 6 equals 24, and adding both sides, 6 to both sides, we get that x is indeed the number 30. Over on the other side here, I'm going to multiply both sides of this equation by -1. When I multiply the left-hand side by -1, this becomes a positive outside of the parentheses. Dropping those, I get an x minus 6 equals, and again, I've got to multiply the other side by -1 also, which is producing the -24. Again, we're adding 6 to both sides. And when I add 6 to this side, x is going to equal not -20, but 2 less than that, so -18. Again, I come back in, and this time I'll demonstrate checking my answer with my handy-dandy calculator. So I'll put it right here. In one case, I'm going to go ahead and take 30 minus 6. So that's always fun. 30 minus 6. And Mr. Roberts, that's 24. The absolute value of 24 is 24. And then I'm going to double that, and I get that the answer is 48. On the other side, I've got -18, I believe. So I'm going to take negative. Notice I'm hitting this button right here to get the negative, right? So the opposite of 18 minus 6. When I do that, I get -24. Now it turns out the absolute value of -24 is 24. So this again becomes 2 times 24, which is again 48. Lovely. Move along. 23. Same thing, I need to isolate the absolute value portion first. The absolute value portion is pretty straightforward, but in order to get it alone, from each side of this equation, I'm going to subtract 4. And I guess I'll write it over here. This is going to become 5 times the absolute value of x, and that will equal 79 minus 4 is the number 75. I'm sorry. And then to complete getting the absolute value portion of this alone, I'm going to divide both sides by 5. So that gives me that the absolute value of x is equal to 75 divided by 5. So 5 1 times 5 is a 5. Subtract 7 minus 5 is 2. 5 goes into 25. 5 is 15. So I've got the absolute value of 15. In order to drop the absolute value, I'm going to have to consider both the positive case or this case. And of course, this results in the answer that x equals the -15. So here we have that it lives in two places. X is either positive 15 or x is -15. And if I look at my original equation, either case, the -15 is positive 15, positive 15 is positive 15. So it's 15 times 5, which is 75. 75 plus 4 is 79. So both the negative and positive check. All right, so now we're going to look at some inequalities. And the instructions here are to graph them as well. When I look at this, again, I need to isolate the absolute value portion of the inequality first. So I am going to divide both sides of this by positive 2. And I'm saying positive 2 just to remind myself that if I was dividing by a negative value, something would happen with this inequality relationship. So this becomes the absolute value of x minus 1 is less than 7. So we want the difference between x and 1 to be less than the number 7. This is the absolute value symbol less than. So it is going to result in an and relationship. So we're going to be looking at a range here, the places where the difference is less than 7. The difference is less than the number 7. So both of these conditions have to be true. So it's an and relationship. Same exact thing I'm going to do. I'm going to write the plus case. X minus 1 is less than 7. And we're going to consider the opposite of that. X minus 1 is less than 7. Over here on the left-hand side, I drop my parentheses. X minus 1 is less than 7. Therefore, x must be less than the number 8. And my other condition, I'm going to multiply both sides of this inequality by negative 1. When I do that on the left-hand side, I get x minus 1. And on the right-hand side, I would get a negative 7. Pausing for a moment, I realize that I've multiplied by both sides by negative 1, and I'm going to flip the direction of my inequality. So it is now x minus 1 is greater than negative 7, and adding 1 to both sides, adding 1 to both sides, we get that x is greater than negative 6. So on each side, I added a positive 1. So if I was to graph this inequality, right, there's a range here, and the first thing says that it is strictly less than, so I'm going to be using open dots at my boundary points. On one side, x's must be less than 8, so here is 5, 6, 7, and here's 8. I have an open circle at 8. Oh, that's a very faint line. There we go. And on the other side, x's are greater than negative 6. So here's negative 5. This is negative 6. And again, I have an open boundary point at the negative 6. And my x's are those values that live in between here. So all the x's that are both less than positive 8 and greater than negative 6 are solutions. So my solution set is everything between those 2 points, but not including those points. And our final question we're going to look at is 33. This is one of about, I think, 4 word problems. A snack company is filling bags with pita chips sold by weight, pretty typical. Each bag should contain 8 ounces of chips. The specification allows for a difference of 1/4 of an ounce, 0.25 ounce. The function f of x equals the absolute value of x minus 8 represents the difference between the weight of the bag of chips and the specification. Graph the function. What weights meet the specification? One of the things that I know is I can look at this totally graphically, but I also want to look at it algebraically. I know that this relationship here, the absolute value of x minus 8. This is the function that represents the difference between an actual bag and the specification. Remember, the reason why this is an absolute value is bags could be slightly more full than the 8 ounces, and they could be slightly less than that. And if they're slightly more than 8 ounces, this would be a positive number. If they're slightly less than it, this would be a negative number. But in all cases, we want the difference between the actual bag and the specification to be, it says it allows for a difference of 0.25. So it has to be less than or equal to 0.25. So this is the absolute value inequality that'll give us the range of values for our chips. I'm going to solve this algebraically before I graph it below. In doing so, I'm going to write this in the two different ways we did up above. Right, this is going to be x minus 8, and we're going to consider the positive case, and I want that to be less than 0.25. And then I've got I'm sorry, I always write the positive one on this side, sorry. And I'm going to look at the negative case, x minus 8 is less than or equal to 0.25. Why do I write the negative one on that side? I don't know. So if I solve this again, I drop my parentheses on this side. It's going to be x minus 8 is less than or equal to 0.25. And on this side, it's going to be, once I multiply both sides by negative 1, x minus 8 is, the other side is going to be a negative 0.25. And the direction of my inequality switches. Adding 8 here, by the way, this is a less than, so this is going to be an and relationship. For this particular one, I'm going to now add 8 to both sides. So I get that x is less than or equal to 8.25. And on the other side, I'm going to get that x's are greater than or equal to, let's see here, it's going to be 8 minus a quarter, which would be 7 and 3/4, 7.75. So my x values that are allowed are going to range between those particular numbers. In terms of graphing this function, I'm going to come ahead and, this is the function that we're graphing, right? f of x equals the absolute value of x minus 8. So I'm just going to consider a couple key values and then draw the lines that go through those. Let me grab this blue pen. So for example, if x is, I need a thicker pen. Sorry, class. Let me try that. If x is, I can pick a few values here. If x is 0, let's do this. If x is 8, right? If x is 8 minus 8 is 0, then the function f of x would produce the value 0, right? So if the function is, if x goes into that function, 8 comes out of it. If I was to place into that function the number 7, 7 minus 8 is negative 1. Absolute value of negative 1 is 1, so it would produce a 1. And on the other side of that function, if it was 9, right, if the function was 9, 9 minus 8 is 1, and the absolute value of 1 is 1. So I've got these values that I want to consider, and I want to plot just those to start with. So one of them is right here at 8, 0. The other point that I was talking about was at 7, I'm going to have a value of 1. So at 7, I'm going to come all the way up here to 1. And then the other one is at 9, I'm going to go all the way up to 1 also. Now, when you look at that, that is a very, very, sharp point right here. So most of this graph is going to be unused. I think I can grab a line tool here. Let's see, line. Here's a line. So if I'm starting here at 8, this function is going to go right through there. And same line tool. If I'm here at 8, it's going to go right through there. And I did a terrible job of going right through those functions. Now we're interested in the range of values where this difference is less than 0.75, right? Oh no, 0.25. We're interested in that when it's less than 0.25. Well, I'm going to come along and I'm going to graph that line 0.25. And let me pick a different pen and same line tool. But right here, let's see, this is 0.2, this is 0.3, so 0.25 is in between these two lines. So I'm going to draw this line right through there. And what I have here is this zone, which is almost impossible to see, right? If I just kind of come down here, it's from like here to here. This tiny little interval on here are the bags of chips that are allowed based on this specification. Now, I'm really glad that we solved this algebraically. Definitely the graph is confirming what we saw algebraically, but you can see up here that the chip bags are having to range between 8 1/4 and 7 3/4. That means that if I'm sitting right here, right at the line, the way this graph was set up for you, this is the number 9, and this is the number 7. Well, 7 3/4 is right there, and 8 1/4 is right there. So it's a very small interval, just right in between here. And in that interval, those would be the bags of chips that would be allowed, because you can see we have a very small allowed difference. It can only vary by 0.75. Now, if you wanted to get to really sloppy manufacturing, you could say, hey, the chips can be anywhere from, 8, this would be 2 ounces up here at the top. You could say, hey, they can vary by as much as 2 ounces. Well, that would be terrible, because some people would be getting, like, they got a bag of chips. Some would get like 10 ounces, and some guys would only get like 6 ounces of chips. So you can see why it's important that we're concerned about in these manufacturing processes that our tolerances are pretty small, so that we are getting kind of uniformity in the products that we're sending out to market. This is Mr. Roberts signing off. Have a good evening.